We're looking at homework from section 4.1. This is question number 18. Use the probability distribution to complete parts A and B below. The number of defects per 1,000 machine parts inspected. The first line of our table is the number of defects, which numbers from 0 through 5. And then the probability of obtaining each one of those numbers of defects is in the next row. So part A says find the mean, variance, and standard deviation of the probability distribution. Part B says interpret the results. So for the mean, we have a formula. The formula for the mean is sigma of x times p of x. We're going to take each value of the random variable and multiply it times its probability, then add up all those products. So we have 0 times 2.60, 1 times 0.304, 2 times 0.244, 3 times 0.134, 4 times 0.044, and 5 times 0.014. When we add those together, we get 0 plus 0.304 plus 0.488 plus 0.402 plus 0.176 plus 0.070. And that gives us a grand total of 1.44. That's our mean. It wants it rounded to one decimal place, so we get 1.4. To find the variance, we have a formula. And there's two formulas. We're going to use the easier of the two formulas. Sigma squared equals the sum of each x squared times its probability. And then once we've computed that sum, we subtract the square of the mean. So this is going to look very much like what we did when we found the mean. We're going to take each number of defects and square it, then multiply it times its probability. So 0 squared is 0 times 260. 1 squared is 1 times 0.304. 2 squared is 4 times 0.244. 3 squared is 9 times 0.134. 4 squared is 16 times 0.044. 5 squared is 25 times 0.014. And then we subtract the square of the mean. So we subtract 1.44 squared. When we compute these values, the 0 times 0.260 goes away. So we end up with 0.304, 0.976, 1.206, 0.704, 0.350, and then we subtract 2.0736 for a grand total of 3.54 minus 2.0736 is 1.4664. Rounded to one decimal place is 1.5. That's our variance. To find the standard deviation, we always take the square root of whatever we got for the variance. So sigma equals the square root of sigma squared. We're going to use the entire value, not the rounded value, not 1.5. We're going to take the square root of 1.4664. That ends up being 1.21095004. Rounded to one decimal is 1.2. So how do we interpret this? We've got a mean of 1.4. So the average batch of 1,000 machine parts has 1 or 2 defects, right? Because 1.4 is somewhere between 1 or 2. So what we're going to choose here is 1 or 2 defects. The standard deviation is 1.2. So the typical number of defects in a batch of 1,000 deviates from the mean by about 1 defect. Okay, so those are the correct choices. Those underlined values would go to fill in those blanks. And that's your answer.